Assalamualaikum and hi everyone. Today I want to continue our chapter 3, Bipolar Junction Transistor DC Biasing. A new topic in this chapter, which is Common-Emitter configuration, or we call it CE configuration, will be explained in this video. To get the CE configuration, apply the proper biasing, which are VCC and VBB, and also the grounding at the emitter terminal. As you can see here, the NPN transistor and also PNP transistor are arranged in CE configuration. Can you see the difference between these two transistors? The polarity of VBB at NPN transistor is in positive, and the VB at the PNP transistor is in negative. It means that the BE junction is in forward bias and the CE junction is reverse bias, so that the transistor is work well in active region. In CE configuration, the input terminal is between terminal B and E due to ground at E. The output terminal is fixed between terminal C and E. As you can see, the input current is IB and VBE is the input voltage. Then the IC is the output current, while the VCE is the output voltage. There are two graphs in this slide. The first one is output or collector characteristic, and the other one is input characteristic. By examining the input, plotting the VBE and IB, the output VCE is fixed at VBE equal to 0.7, remain the same. VBE equal to 0.7 is applied to all transistor configuration, including the CE configuration. And for the PNP, the VBE is equal negative 0.7 or VEB is equal to 0.7. There are three regions of operation, which are active region, cut-off region, and saturation region. These regions are similar with the common base configuration. In active region, the relation between IE and IC is very different from the common base configuration. This relation can be defined as IC equal to beta IB, where beta is the ratio of IC over IB. The cutoff remains the same with common base configuration, where the IC current is 0, which is in open circuit equivalent. The saturation region also remains the same with the common base configuration. Output collector emitter voltage is 0, which is short circuit equivalent. How to determine the biasing, forward bias or reverse bias arrangement for a common emitter NPN transistor configuration? Take a look at the second figure. The PN junction should be in forward bias, while the NP junction should be in reverse bias. So we apply positive VBB at PN junction and positive VCC at NP junction to get reverse and forward bias. When we have this kind of biasing, it means that this transistor operates in active region. Now you can try this question. Sketch the biasing arrangement for these two common emitter and PN transistor configuration so that the transistor is operate in 1. cut-off region, and second, saturation region. From the output characteristic of the common emitter configuration, we get the equation of IC equal to beta IB. From the equation IC equal to beta IB, the ratio of IC over IB is beta equal IC divided by IB. Beta is a constant value that range from 50 to over 400. For the IE, substitute the equation IE equal to IC plus IB into the beta equation. And we get IE equal to beta IB plus IB. Please remember these two equations because we want to use it in DC analysis. A relationship can be developed between beta and alpha using the basic relationship introduced thus so far. Substitute all of the equation in terms of beta into the alpha equation. We know alpha is equal IC over IE, and now it become beta over beta plus 1. For the beta in the terms of alpha, beta equal to alpha over 1 minus alpha.